Okay, so as I was saying, what today we're going to take a look at is documents that have malware in them rather than executables. To that end, tend to be more static in nature when we're analyzing these kinds of malwares. We don't have to do dynamic analysis. We don't have to do behavioral analysis. I don't want to speak in absolutes, but what we're doing when we take a look at these documents is much more static in nature. Because of that, and because most of the tools are available to us, we only need to run Remnux for today's class. I suggest running Remnux off of your VirtualBox instance, but again, it's up to you. You can do whichever you prefer, okay? So, as I was saying before, I had the wrong screen displayed. I apologize. So what I suggest is that I suggest you have Remnux running off of VirtualBox for today's class. There's also benefit in having the lecture notes available as well, because there's a couple of files you're going to need to download for today's analysis. Alrighty? Any questions? Okay. So, is there a question? Does somebody have a question? Okay. So in the past, PDFs were a common vector of attack because PDFs aren't actually compiled documents. They're text documents. They can have some binary data embedded in them, but the structure of a PDF document is very text-like in nature, as we'll see in a couple of slides. Back in the day, information security people used to reference PDF as payload delivery format rather than public display format, or whatever PDF really stands for. And it wasn't so much that the PDFs themselves were dangerous. It was the readers that were in place. Adobe has a long history of pushing software out that is just riddled with security holes, and the Acrobat Reader was notorious for having a lot of vulnerabilities in them. They've gotten better, okay? They've gotten much better over recent years, but there was a time when the Acrobat Readers were a huge security risk, as well as the Shockwave players and the Macromedia Flash players and all the other ones. Some of the vulnerabilities seen in PDF documents can include embedded JavaScript, Flash, or other rich media. It calls for external programs, and that's what we're going to see today when we're looking at our attacks, and interactions with other websites as well, just calling websites and throwing data to them. As I said, PDF files are very much a text-based, non-binary format. They can contain binary objects, and we'll see that today, but the structure of the PDF documents are very text-based in nature, looking something like this. Okay. Inside the PDF document are a series of objects. The objects are numbered, and they're also given version numbers as well. So for example, if you take a look at the middle bullet on this page, object 1 can have version 0, and then there can be version 1, version 2, version 3 of object 1. Okay? Each object must have a unique number. The tricky thing is that these objects can refer to other objects as well. And that's where we start running into some problems with our objects, is when they start calling other objects, that's when you have to sort of crawl through the document to see what's going on. And we'll see that today with our second PDF analysis. Any questions? Okay. If you haven't already done so, please fire up Remnux. If you haven't already done so, log in. And what I want you to do is, first off, we need to create a directory structure. I'm going to make a directory called a PDF. Okay, in the notes I saw it call it CTK. You can call your directory whatever you want. At this point, your workflow is your workflow. And then once you have that, you want to wget the file that I have listed in Learn. Git project 05.academic.rrc.ca secu SECU-1009. Oh, no, no dash, sorry. SECU-1009. And then ctk.zip. If I haven't screwed up the command, what I should get is a 200 status code. It should show that it has downloaded 100% of the file, and it was, I can't remember how big this is, 957 bytes? I guess it can be 957 bytes. Okay, and then you should see ctk.zip in your directory. Once you've done that, you can unzip ctk.zip. The password, as is usually the case in this class, the password is malware, all lowercase. M-A-L-W-A-R-E, all lowercase. So that now you have, oh, that's no good. I need to lessen that by 1. Let's try that. No. Oh, that's fine too. Actually, that's perfect. Okay, so you should now have a 1.5 kilobyte file called ctk.pdf. Any questions? Okay, I'm going to focus inside of Remnux right now, but again, as I said, there is benefit in having this PDF available at the side. If I go too fast, please let me know, and if I miss your talking, let me know as well. Yes, please go ahead. The password is malware. Okay, one sec. Options, edit. Actually, I'm sorry, but I need to do this anyway. I need to make my font bigger, because we're going to be in this right away. Edit. Paragraph. No. File. Encoding. Edit. Yeah. Language. No, it's not a language thing. Option. Anyway, I can't find it. I apologize. To make the font bigger. Somebody can find how to make the font bigger, I would appreciate it. But I'll also tell you right now that if you, inside of Teams, if you move your mouse on top and hit the Control key, you can zoom in on what I'm typing. So maybe you can zoom in and out as I'm going through today's class. Because at the end of the day, one of the things I want to do is to take a look at ctk.pdf in Site. Okay, so you can go launch Site and go File, Open, or frankly, you can simply go Site, SCI tab, space, CT tab, P tab, autocomplete, tab is your friend, and then of course the ampersand, so that it can start the process and then give me my command prompt back. And when we do that, we see that we have what I said. This is my PDF document. It's not that big. It's a very small and easy to understand PDF document by design. Okay? When we take a look at this document, we see the examples. God, I wish I could make this font bigger. Anybody find how to make the font bigger? Control plus. Whoever that was, thank you very much. Thank you very much. The plus on the keyboard worked. Perfect. Thank you. Who was that? Thank you, Sukhjit. I much appreciated, sir. And one of the options is to do a word wrap. I kind of encourage that as well, so it's a little easier to see what's going on. Thank you, Sukhjit. Very much appreciated. But the big thing is here's our examples of objects. Object 1, Object 2, Object 3, and then each object has its own corresponding end object tag, just like an HTML document, I guess. Again, we can see right away something suspicious. This is a PDF document talking about opening up a PowerShell and then passing some encoded text to that PowerShell, which is immediately suspicious and something we need to take a look at. Does everybody see that? Okay, perfect. Yes, thank you. So, sorry, I'm recording this, I shouldn't swear. Okay, so, where was I in my notes? I don't want to miss anything. Talked about that. We talked about that. Okay, so, first thing we take a look at this is that there's also an open action tag as well. And with that open action, they're doing a launch, and within that, they're launching this call to PowerShell. So right away, object 1 is doing what's called an open action, and this is what happens, obviously, when the document gets loaded, which is also suspicious. Okay? The /s tells it what to do, and it's launching a window, and then the command is doing with that open window is the /f switch. And right away we see that it is doing a PowerShell session, but as I said, there seems to be an encoded command argument passed to it, which looks to be this block of text here. Now, I would like you to highlight that block of text in your text editor, okay? Up to the equal sign. Everything from UAB right down to the equal sign. All of that text I would like you to highlight and copy, please, because that's encoded text and we want to understand what that is. Okay? There's a couple of ways, and I'm sure you're getting tired of this, but frankly, I don't care. I hope that's recording properly. There's a couple of ways that we can do a lot of these tools, and I keep showing you different ways of doing these tools. I do that on purpose because I want you to be able to try different things in case there's some kind of obfuscation being done on one of them. So one of the ways we're looking at, and I'm on slide 12 of today's handout, is that we can simply use the base64 command with the /d. Okay, how does that look like? Well, you can actually I think you can see it on the next page. You can see it on page 13, but this is what it looks like. It's base64, and you can use the tab key and it should autocomplete, -d for decode, and then it's just sitting there waiting for inputs. And then at this point, because we copied this, again, highlight everything from UAB right down to the equal sign, right click and copy. Back here, right click and paste. And now we've pasted into this base64 interactive command the encrypted code that we want decrypted. To tell it to decrypt, we hold down the control key and hit D. I suggest the control key on the right side of your keyboard. You might have to hit control D a couple of times, okay? And then we can see it. Here it is right here. PowerShell execution policy, bypass, no profile, window style, hidden command, download an executable, and then launch that executable. Now, if you don't think that is suspicious behavior, you might actually be in the wrong program, because that is extremely, extremely suspicious. So let's just do that. Let's highlight that code, right click, copy, and we're going to take a look at that code in sight. There it is there. PowerShell execution policy bypass, no profile, Windows style, hidden, command, new object, download file, and this is just what batshit crazy, right? And then it's moving it to the app data folder, and then it is launching that executable. Very, very, very suspicious behavior. Okay? So that's one way of understanding what's going on, and it allows you to, as part of an overall defensive team, come up with a mitigation against it. Okay? In most cases, the copy paste will work. If it doesn't work, it's probably because you failed to collect all of the text when you tried to do your copy paste. There are other tools that are available as well. There's a tool called base64dump.py. Let's take a look at that one now. Okay. If we do base64dump.py and tell it to check out ctk.pdf, it'll do a brief dump of all of the different things that it comes across. It's an abbreviation. Okay, this is a simple output and abbreviation of the information that it came across. It found, by our analysis, something suspicious in object 2, okay? In ID 2 or object 2, or actually let's take a look and make sure. No, it's object 1. So this is not an object ID, this is just an overall ID that it came up with. So when it took a look, it found this, 600 bytes in size, and it starts with a PowerShell call. Immediately suspicious. We want to take a look at this ID2 content. Base64 dump will allow us to do that. Okay? We can do base64. Well, actually, we can hit the up arrow. Base64 dump.py, ctk.pdf. We want to look at ID2, and the uppercase S indicates it to decode it into ASCII text so we can look at it. So when we, again, what did I do? The first time I typed in base64 dump.py and then ctk.pdf, and it gave me this information. I'm interested in ID2, so I'm going to tell it -S2, which tells it to look at ID2, and then -uppercase S is telling it to decode it and present it in ASCII. When I do that, I get the encoded text. And it is, again, very suspicious and similar to what we saw, in that it's telling it to download an executable, it's moving it to our app data folder where we saw that BRBbot likes to run, and then it launches it at that point. Very, very, very suspicious behavior. And the beauty of this is that we're running this all in Linux, so this threat is not a threat to us. Any questions? Does that make sense? Again, a screen capture can be seen on slide 16 of today's presentation. When we look at this, I talk about this on slide 17, but what we're doing is we're launching a PowerShell. It's doing the bypass, which bypasses execution policies in general. It shouldn't be possible anymore. This is an older virus, but at one time it was bypass. You could bypass execution policies. It will try and run in a hidden window. It will then execute a web client. It will download the awri.exe file. It will then move it, as I said, into the app data directory for your user profile, which is the env variable. And then it will execute that awri executable in your app data folder based on your environment. Okay? Note that most newer versions of Acrobat will not play this. Okay? Other readers might, but again, most readers have gotten pretty good at mitigating these kinds of attacks just because it has been such a huge problem. Are there any questions? Does that make sense? On slide 18, there is another file I would like you to get. Again, I'm in the directory where I'm working on my PDFs. Perfect. So I'm going to wget bitproject 05.academic.rrc.ca.secu.seu1009 and then collab.zip. A 200 status, perfect. An 8K file, perfect. Then I can unzip collab.zip. The password is malware again. Okay. All right, just like before, the password to download this file is the same. I'm not typing that again. So that's what I did. I did wget, and then when I did an unzip, and when it asks for the password, I supplied the password, and it is malware. Okay. A screen cap of the process can be seen on slide 19 of the PowerPoints for today. Any questions? Everybody at this point? Very good. So now that I have done some basic analysis, I want to show you some other tools as well. I don't know if you recall when we were looking at Mr. Robot last semester, and I was telling you about all of the tools in Mr. Robot that are available, or all of the tools in Kali that are available for WordPress attacking. And the reason why there are a lot of tools in the Kali distribution for WordPress attacks is because WordPress was so notoriously vulnerable. The same can probably be said about Remnux, and that there are a lot of tools in Remnux for PDF analysis. We've taken a look at a couple. We're going to take a look at a couple more, but I just want you to understand why there's so many different tools is because PDFs were such a problem for such a long time. Okay, we're going to use a lot of these tools, again, just like with our pen testing analysis of WordPress sites. We're just going to scratch the surface because there's so much out there. Okay, the next tool we're going to look at is PDF ID, and what this tool can use is it can take a look at all the different parts of a document, and it will try and report any that it thinks might be suspicious. We do this again in the terminal with PDF ID tab, and it'll autocomplete to pdfid.py, and this time, well, we want to take a look. We've got the collab.pdf perfect, so we want a pdfid.py, tab is your friend, collab.pdf, not the zip files, the PDF files. And when we run that, it runs through and it does analysis and it shows what it thinks might be suspicious. It has an open action. We've already seen those to be suspicious. It has some JavaScript and JS files. It has 3 JavaScripts and 1 JS, or 2 JSs. So the 2 JSs are part of the JavaScript, I would imagine. There's an open action. There's a rich media. No, there isn't a rich media, so that's good. There isn't any embedded files either. But we have an open action, maybe a form. What's up with that? But we have some JavaScript. So we want to take a look at those different parts. Okay. So we do see JavaScript is included. There's also some JS calls, which is also included in the JavaScript. And as I said, there's an open action and a form. Okay. And there's a page numbering. Oh yes. And there's only one page as well. Okay. Now one page by itself is not a bad thing. But when you see JavaScript and open action and only one page, at point one page can also be an indicator that this might be a suspicious document. I don't know if every time you see one page, if you need to stop and say, okay, this is a malware. I don't think that's necessarily true. It is, of course, possible for there to be a single page PDF, but a one page with other indicators, I would definitely stop and take a look at that document. Because of what we're seeing here with our PDID, there's some suspicious stuff. We need to take a look at it in a little bit greater detail. Okay. Is PDF Parser installed? It is. So next thing we're going to take a look at is PDF Parser. All right. What we want to do is see if we can find any of the JavaScript code that we saw. So we're going to do pdfparser.py, tab is your friend, collab.pdf, and we're going to search for JavaScript. We're going to pipe the results to less so that we can scroll through, but we can also, because we've got a terminal with a scroll bar, we can actually use our scroll bar as well. I don't care, that's really up to you. But you can see here that when we take a look at this document, we have some JavaScript referencing object 10. Now we don't actually see object 10, but we've got a JavaScript call calling on object 10. We've got an object 12 referencing object 13, and then JavaScript 13. So we see something indicating that there is something wrong with objects 10, 12, and maybe 13. Okay. Object 7 is doing a JavaScript call for object 10. Object 12 is referencing object 13, which is another possible JavaScript call. So I want to take a look at all of those. There's also this object 1 that has some JavaScript with it as well. So we should really be taking a look at this, and that's what we talk about on slide 25. Object 12 references object 13. Object 13 we may want to take a look at. Actually, we want to take a look at a lot of these things. Okay. So let's take a look at, let's start doing it. Once you're inside of this, because we've piped it to less, you can scroll up and down. Well, you can scroll up and down, right? And at the end, you can just hit Q to quit. Okay. We can use our command again. No, let's not do that. PDF parser.py collab.pdf, and this time we want to tell it to look at object 10. And when we do that, object 10 has some strings in it. Okay, so let's take a look at 12. Object 12 calls object 13. Let's take a look at object 13. It contains a stream and it does a flat decode of something. Okay. So what we're going to do is we're going to try and have it decode that information for us. Sorry, excuse me. We can actually have it analyze it and output the results. And that's what we're going to have it do next. Again with our PDF. If you're curious, type in PDF and hit tab a couple of times. And that gives you an idea as a number of PDF tools that are available to you. Again, how did I do that? I typed in PDF and hit the tab key twice. And those tools that it can find that are in the executable path. I'm pretty sure there are even more Python scripts in other places that you need to call directly. But that's just what it can find in the path for PDF analysis, which is pretty cool. So PDF parser.py collab.pdf again. We want to look at object 13, object space 13 space, and then we want to filter raw, and then we want to decode it into collab.txt. I don't care what you call the output file, but we're dealing with the collab.pdf. So the first time I try and decode this text, I'm going to output it to the collab.txt file. ls, and then I can take a look at the collab.txt file. Well, we're getting closer to something. As you can see here, there's a lot of code in this collab.txt file. There is a lot. Okay? Interesting. I'd say there's still a little bit of hijinks going on. Not exactly sure what's going on. There's clearly some obfuscation going on. But if you recall, this was a JavaScript call. So this is an argument that's being passed to JavaScript. So clearly somebody has gone in and done some JavaScript obfuscation to hide what's really going on here. It's actually worse. It's not just JavaScript, but there's also a bunch of binary code or shell code embedded in this malware as well. So once it does the JavaScript, it then calls the shell code, and then it tries to run that. But we'll see that in a little while. Okay? Did everybody get that? This is what I did. All right? I saw that there was some interesting stuff in collab.pdf, and if you want, we can take a look at it again in Cite. Collab.pdf ampersand. And when we take a look at that in Cite, you can also see the different blocks of code that might be interesting. And then right away we've got this weird stream going on with object 13, so we really want to take a look at that well. So even the old tools don't fail us at this time. There's something weird going on with object 13, and then we can see, where's object 12? Object 13, object 11. Object 12. We can see object 12 calls object 13 with JavaScript. And when we look at object 13, we see this weird stream that we really want to understand. So even, even the old opening up the PDF in a text editor is still worthwhile in this case. If you recall, the first time we took a look at malware, malware. The first time we took a look at malware, I had you use hexdump and vbindiff, and really we haven't used them since, because most of the malware we look at, that's not going to work, because most malware is packed as an executable, but the malware we looked at wasn't packed, so we actually go through and find suspicious code. Even opening up suspicious PDFs in a text editor is never going to be a wasted effort, because it's pretty easy to understand and you can right away see suspicious content. And the more you do it, the better. So don't ever be afraid to open it up in a text editor. I know when we did that with vbindiff, we only really used it on one or two examples. That's not the case with text editors and PDF documents. Any questions on that? Does that make sense? Okay. So again, what did we do? We took a look at our document. We saw some suspicious bits. We looked at them in greater detail, object 10, object 12, and object 13. In object 13, we saw something that might have been encrypted, so we told it to decrypt it, and we output the results to collab.txt. When we took a look at the collab.txt file, when we take a look at it, we can tell that this looks suspicious. It still looks like it might be obfuscated or at least encrypted, but you know what? It doesn't look encrypted because there's a bunch of equal signs and spaces, and it doesn't really look encrypted to me. This just looks like it might be obfuscated. It might be JavaScript, given that it was supposed to be something passed to a JavaScript call. I'm thinking it's JavaScript code. So what I want to do next is I want to say, hey, let's run this JavaScript and see what we get. And that's what we're going to do next. Any questions on that? Okay, before we do that, we want to take a look at another way of extracting this. And there's a utility called Peepdf, or it's called Peepdf. It's to take a look inside of PDF documents. It has a really unfortunate name. It looks like you're taking a P on a PDF document. I didn't name it, but this is what we're going to take a look at. All right. The tool is called peepdf.py. Maybe it doesn't require the .py extension. -fli are the arguments. F to force it to ignore errors and keep parsing it. L to loose is a loose mode to try and catch as many objects as possible in case they're not properly designed. And I means that we're going to do an interactive shell. And then we're going to look at collab.pdf. So we're in an interactive shell. And now we can take a look at the results. And again, it's showing us all the different pieces that are available to us. We can start taking a look at the different parts. And again, we can tell it to take a look at object 12, which then calls object 13. We have them all listed here. So we can, how do we do this? Here it is right here. We can say object 12. When we look at it, it says, no, go to object 13. Fine, let's look at object 13. And then again, we see the stream as something that we can understand, because this tool will try and make it as easy to read as possible. Again, we can say, okay, stream 13 is interesting. I want to extract that. So we can say stream 13, and I want to extract that out to, let's say, collab2.txt, which is what I have in the notes. So now that I've got that, then I can exit out of my Peepdf interactive console. Now I have collab2 and collab.txt. And really they should just be just about the same size. 17 kilobytes. 17.5 kilobytes in size. They're exactly the same size. Something that's not in the notes is FileCompare installed. Good. Okay, it's not going to work. That's not the right command. Anyway, don't worry about it. There's a FileCompare command, and I'm drawing a blank on it right now, so don't worry about it. What was I going to do next? Okay, now we've got this. Rather than try and debug the JavaScript, what we can actually do, just like we do with X4 debug, where you load the malware and then you run the malware to allow the program to decode itself, we're going to run JavaScript to allow it to decode, to unobfuscate the JavaScript code. There's a built-in JavaScript runner. It's called Script Monkey or Spider Monkey. I keep calling it Script Monkey, but it's called Spider Monkey, but the command is simply JS. All right. So we're going to type in JS, and we need to specify the F argument to tell it to use an object library. And as usual, it's in user share remix objects.js, and then we're going to specify a file to parse, collab.txt. And when we do that, it says, hey, there's a problem with this function. This high LTLZYR function is not a function. Okay? So even further obfuscation is going on, and we need to fix that. And this requires a bit of JavaScript programming. If you don't JavaScript program, I understand, but we're going to take a look at the code anyway. I closed down collab2 text, but I left collab.txt open in my text editor. And in our error, it mentioned this string here. Copy that, and then search, find, paste that, and it takes me right away. And it's very early on. And this highlister is actually saying it's not a function. But when we look at this, it doesn't look like a function. What it looks like is a collection or an array. Okay? And it kind of looks like a multi-dimensional array as well. But the last item in that collection of collections, is eval. It's the only thing that makes sense in it. The rest of it kind of looks like gibberish. So what I'm going to recommend is we get rid of all of that information and just have eval. Copy eval, cut eval, and then get rid of everything else. The square bracket right up to the round bracket, because the square brackets are delineators here, and then the round brackets are delineators there. So I'm going to change that function to simply eval. I got rid of everything else. Again, how did I do that? When I took a look at what this was equal to, okay, because it's kind of got a bracket here and then a square bracket alongside of it. So it's basically saying this unusual function call that the JavaScript spider monkey said was a function call looks like it has some kind of a weird list or array or whatever. Drawing a blank, sorry guys. But the only thing in there that makes sense is eval. So maybe it's iterating through all of that until it gets to the last one, and then it's going to do that function. There's an extra degree of obfuscation happening here. Fine, no problem. If it wants eval, I'm going to get rid of everything right up to the semicolon, but not the semicolon. So I highlight everything from the opening bracket down to the closing square bracket and substitute that for eval, E-V-A-L. So now that weird function name is simply equal to eval semicolon. Save that, and then try running your spider-monkey command again and see what you get. And right away we see that it looks like it might have decrypted it, but as you can tell, it does it's quite a bit of stuff going on here. Okay. There's weird function names, and then it's doing some more weird stuff. But the most important thing is that it's getting into binary or bytecode. And that's what we need to look at. Oh, have I missed anything? So now that I've done that and it's thrown it to the screen, I'm actually going to redirect that now to a third file. And I'm going to call it collab3.txt. If you can use whatever you want. So now I take a look at collab3.txt. In my preferred text editor, we again see what this created for us. Quite a lot happening on. Still a little bit of obfuscation going on there. We might need to fix that later. But right away, you get this indication of something weird. And this weird is actually executable code. Okay? It's shell code. That's what we're going to call it. It's some kind of an executable to probably launch a shell from within an Acrobat reader somewhere. Okay, it's probably designed for some specific old vulnerability that used to exist in Acrobat Reader. May or may not be relevant anymore. Probably not. Very unlikely that it is relevant anymore. I tend not to use bleeding edge viruses in the class. Okay? But now we've got something we can try and analyze further, which is what we're going to do in our next class. And as you can see, it's quite a bit bigger. There's a lot of text in this function that we were able to decode. As I was saying, it's an easy read what's going on, but there's obviously a bunch of shell code or executable embedded in that as well. And it's represented by a series of bytes that just look like assembly instructions. And to be honest, we could take this assembly instructions and take a look at it at disassembler. We can take a look at those things as well going forward. Okay? Are there any questions? Does that make sense? Okay. I'm going to give you the rest of today to get ready for our class for tomorrow. I want you to, for the next class, I want you to make sure that you have analyzed the contents of collab.pdf, as extracted the important bits as collab.txt, produced another one called collab2.txt, showing me that you've used the two different tools for extracting the interesting object 13 code out to a text file. Once you've done that, deobfuscate it with a script monkey so that you have a collab3.txt. Now, I don't care what you call the files, just make sure that you have those in place for the next class. Okay? Any questions? Alrighty. That's it for me. I'm going to stop the recording for today's class.